For years, software development was limited by how fast an engineer could type. Now, code can self-generate as quickly as you can describe the objective. In early 2025, Andrej Karpathy described this shift as vibe coding. It was a prediction that English would eventually become the primary language we use to command computers. The idea was simple: describe a feature in natural language and let a large language model produce the code. If it doesn't work, you simply paste the error message back into the chat until it does. You don't have to understand the syntax, you just have to guide the outcome. This approach allowed non-technical founders to build fully functional prototypes over a single weekend. By the winter 2025 Y Combinator batch, a quarter of the startups were presenting products that were 95% AI-generated. This speed created a massive incentive to move fast. But by ignoring the rules of software engineering, teams were building on a foundation they didn't fully understand. The excitement eventually cooled as teams moved from prototypes to production. They ran into what is now called the vibe coding hangover. The primary cause is context amnesia. Because a standard chat window lacks awareness of a project's specific security rules or system architecture, the AI often suggests generic, insecure code patterns. This chart shows the long-term result. While your perceived velocity starts high, your actual velocity begins plummeting once you hit the wall of technical debt. You're left with security flaws and logic errors that no human can easily debug. AI expert Andrew Ng warned that the term vibe is misleading. It suggests that building software is a casual task, hiding the actual labor and risk involved in maintaining a system. Cognitive scientist Gary Marcus added that these models often rely on reproducing existing patterns. They can copy code that looks right, but they struggle to innovate when a problem becomes unique or complex. To avoid deploying vulnerability as a service, the industry is shifting away from simple prompting and toward a more disciplined engineering model. Vibe coding is essentially a single-player mode. The logic of the system lives in the developer's head. If you forget to tell the AI to secure a database, it stays open. The professional alternative is agentic engineering. This is the practice of architecting specific rules and guardrails that autonomous AI agents must follow. In this model, humans own the why and the how, the high-level design and security policies. The AI agents own the what, the implementation of the code and the repetitive boilerplate. This requires a trade-off. You lose the chaotic speed of a weekend hackathon, but you gain long-term safety by investing in system design upfront. Developers are transitioning from being the people who type the code to the people who architect the system. To solve the context amnesia problem, engineers are turning to context engineering. This means moving the rules of the project out of the developer's head and into the repository itself. On the left, a blank chat window. On the right, a repository using context primitives, rule files like .agents.md. These files force the AI to follow your security standards. If a developer forgets a prompt, the agent still uses your preferred encryption. This approach takes more time to set up. However, it ensures that every person on the team and every AI they use defaults to the organization's standards. By hard-coding the context into the repo, teams can finally scale AI development without sacrificing security. To keep autonomous agents on track, developers are adopting structured workflows, specifically the Spark framework, to define the boundaries of the work. It begins with humans writing detailed specifications and collaborating on pseudocode and architecture. This ensures the AI isn't guessing at the goals before it starts building. Next comes refinement. Tasks are broken down and assigned to specialized agents. One drafts the code, while a tester agent independently verifies the logic. The process ends with completion, where the human acts as final gatekeeper, ensuring the code matches project standards. These agents work within bounded tasks. This prevents the hallucinations that usually happen when you give an AI a large, unstructured prompt. This orchestrated approach ensures that the AI is building a cohesive system, not just writing disconnected lines of code. In traditional development, security issues are often caught during a final audit. If a problem is found, it requires expensive rework to fix. Agentic engineering shifts security all the way to the prompt. By codifying constraints in the repo, you set security rules before the code is even written. This prevents the AI from suggesting bad patterns in the first place. The system is designed to make those errors impossible to even suggest. Creating these watertight constraints requires senior engineers with a deep understanding of security risks. They are the ones who write the rules the agents must follow. The result is a much faster development cycle. Developers don't have to rewrite code after a failed security scan because the AI was never allowed to suggest the vulnerability. Software engineering is shifting away from manual syntax. Your primary value now comes from designing the system, not just writing the lines. At companies like Microsoft, teams are using these agentic tools to manage complex cloud environments, using humans as the orchestrators of the process. Platforms like GitHub are developing repository intelligence, AI that understands the history and relationships of code across an entire organization. The prized skill sets in this environment are systems thinking, clear technical communication, and the skepticism needed for a rigorous code review. Even when AI agents handle the execution, human clarity remains the ultimate bottleneck. To help you decide on a workflow, we can map your project on this quadrant chart based on its stakes and the level of rigor you need. Vibe coding belongs in the bottom left. It is a useful tool for the maturity phase where you are just exploring an idea or building an early-stage prototype. The trade-off here is that you must treat this code as disposable. To scale it into a real product, you will likely need to rewrite it from the ground up. Agentic engineering is the standard for the top right. This is for enterprise teams that require reliability, compliance, and long-term maintenance. The advice is simple. Stop treating the chat window as a source of truth and start engineering your repository's context. Combining human intuition with agentic discipline allows engineers to oversee complex systems that would be impossible to maintain through manual coding alone.